Welcome to assignment 22. This is notes on factoring trinomials. And this is the first time we're seeing this, and I'm going to call it level 1. Okay, now there's going to be a few levels here, okay, because there's two things that make this level 1. One is that we're only going to be working with positives. Okay, and the other thing that makes this a little bit easier than what we're going to get into is that when you see x squared today, there's no coefficient. There's not going to be, there's always going to just be a 1x squared, right? That invisible 1x squared. There's not going to be a 3 there or a 4 there, and you're going to see later on that that does make it a lot harder. Okay, so this is level 1, and we're gonna get through some levels, but right now this is the first time we're seeing it. So here's what you need to know. Factoring is the opposite of multiplying. And one way that we multiply a lot in algebra is we distribute. So factoring is the opposite of that multiplication, the opposite of that distributing. Okay, so let me just kind of show you what that means. So we have multiplied already. We've learned this. So I'm going to show you multiplying on the left, and then that way when I show you factoring on the right, you can see, oh, it's the opposite. Okay, so for example, we have already learned to multiply something like this, x plus 4 times x plus 5, right? And some of you are more comfortable with the box method, some of you are more comfortable distributing, but either way, when you multiply, you do x times x, you get x squared. You do x times 5, you get plus 5x. You do 4 times x, you get 4x, and 4 times 5, and you get 20. And then what do? You combine these like terms, right? They're here, and you get x squared plus 9x plus 20, and that's your answer. Okay? So when you go to factor, the problems will look like this. Instead of saying, okay, multiply, and the problem looks like this, it'll say, okay, factor, and the problem will look like this. Okay, notice, those are the same. The problem will look like this. Now, how do you get from this to this? Because here's the thing, right? These are opposites, so this is the answer. I'm telling you right now, I just multiplied, and factoring is the opposite. So I'm telling you, this is the answer. So how do we get there? Well, here's how we get there. We observe, and we say, I notice there was a 4 here and a 5 here. And look what I ended up with, a 9, because look, I added 5 and 4, and I got 9. And when I multiplied 5 and 4, I got 20. So I took these two numbers, and I did this whole process that I've already learned, and somehow in that process, I ended up with this being the sum of those two numbers added, and this being the product of those two numbers multiplied. So when I see something like this, I remember, oh, that funny thing happens, and I'll show you and it'll happen again, right? What I'm looking for right now is two numbers that add to 9 and multiply to 20. Okay, what are those two numbers that add to this number? They add to this number that's multiplied by x, and they multiply to this number that has no x on it. So what are two numbers that add to 9 and multiply to 20? Well, the two numbers that add to 9 and multiply to 20 are 4 and 5. So that means this is going to be x plus 4, and I could put the 5 first, doesn't matter, x plus 5. That is what a factoring problem will look like. You get a problem like this, you think, okay, let me think, I need two numbers that add to this number and multiply to this number. And once you think of those two numbers, you pop them right here. Okay. Does it get more complicated? Yes, but not in level 1. We're going to get really good at this first, and then we're going to build on it. Let's do another one. Let's say I have something like this. X plus 5 squared. Oh, what does this mean? Look, we know what this means. When something is squared, it's multiplied by itself. Okay, so that's, you can get this. So now let's go ahead and multiply, right? X times x is x squared. X times 5 is 5x. 5 times x is 5x, and 5 times 5 is 25. So then what happens? We combine like terms. Add 5 plus 5, that's 10x. Right, bring down the rest. And there you go. That's another multiplication problem, right? This was my first multiplication problem. Here's my second multiplication problem. Okay, so now when I get a problem, a factoring problem, right? Here's my second factoring problem. It says, okay, factor this. factor this. Well, if I'm looking to factor this, right, what I'm looking for is I'm looking for two numbers that add to 10 and multiply to 25, right? And here, this is the tricky part. This is the part we've been practicing and playing games with, right? So you might need a multiplication chart. But we're trying to think of two numbers that add to 10. We always add to this number and multiply to this number. So what are two numbers that add to 10 and multiply to 25? Well, the numbers are 5 and 5. So then that would look like this. And when I factor it, say, okay, here's my answer. This is this factored. It's broken down. And there's a lot of good reasons why we might want an answer in this format, where we multiply it. And there's other good reasons why we might want an answer in this. Okay, and we don't get too much into the reasons in Algebra 1, but it's important that you're comfortable changing back and forth between these two. Okay, and so you can write this as your answer. That would be totally fine. Sometimes this is also an okay way to write that same thing, right? You can write it either way. Let's look at one more just so you can kind of make sure you sort of have a feel for this. Okay, and this time I'm going to give you this version first so that I'm not giving you the answer first. See if you can figure it out. Okay, I'm looking for two numbers that add to 8, right? I'm always looking for numbers that add to this number, multiply to this number. So I'm looking for two numbers that add to 8, multiply to 7. So when I see this, multiply to 7, I think, well, there's only two numbers that multiply to 7, right? 7 is prime. So 1 times 7 is 7. And do those add to 8? 1 plus 7? Sure do. So here's my factored form. X plus 1, x plus 7. And you could put x plus 7 first, then x plus 1, doesn't matter. Okay, and so notice, right, and you can always multiply to check, right? And I say, okay, if I got this as a multiplication problem, what would I do? I do x times x, I do this, I do this, like that, right? So 7x plus 1x, that's 8x. And notice, look, okay, notice these always undo each other, factoring and multiplying. What starts here, right, becomes this answer, that becomes this question, that becomes this answer. It's all this, it's just undoing each other. Okay, so right now, I want you to pause the video, pause, press pause, and you're gonna factor, well, not the second, wait for me to write down the questions. You're gonna try these two. Use your notes right now. Give yourself this chance to process right now before you walk away from this, because that chance to process is really important for helping your brain remember. Okay, so go ahead and pause. Don't write the word pause, please. Pause the video. Go ahead and try those. All right. Let's do it. Here we're looking for two numbers that add to 8, multiply to 15. What'd you come up with? Did you think of 3 and 5? So that should be x plus 5 times x plus 3. Okay. What'd you come up with here? You were looking for two numbers that add to 10 and multiply to 24. This is a tricky one. There's lots of numbers that multiply to 24. What are the two numbers that multiply to 24 that add to 10? You might think, like, okay, 2 times 12. No, that adds to 14. 8 times 3. No, that adds to 11. 4 and 6. So I would write x plus 4, x plus 6. All right, there you go.